Hello my dear learners, welcome to my video lecture on parameters considered for additive manufacturing. In the previous lecture, I had covered the introduction of additive manufacturing and I also discussed about the stages of additive manufacturing. In this session, I will be discussing about what are the important parameters which are to be considered while additive manufacturing. I am Shamant, Assistant Professor working at Global Academy of Technology in the Department of Mechanical Engineering. If you want to reach out, if you have any queries, do mail me at shamant@gat.ac.in. Okay, we'll start with the important parameters of the additive manufacturing. The first one is slicing of 3D models. So in the previous lecture, when I discussed about the stages of additive manufacturing, the first stage is the creation of 3D model and the second stage is conversion of 3D model into STL file. STL file, I told you that the 3D model is to be converted into stereolithography file, which is nothing but the it has triangulation, or the triangles, the entire geometry is converted into triangles, wherein the transfer of the file to the AM machine will be easy, or the machine, which is nothing but the additive manufacturing machine, can read that file. So here one of the key challenges in additive manufacturing is to slice the 3D models. You can just see here the figure depicts the 3D model. Rabbit is a 3D model, and you have thicker layers, then you have thinner layers here, and the combination of both thicker as well as thinner layers is also present. So what do you mean by slicing? Slicing is nothing but your model is cut into horizontal layers based on the thickness of each layer and calculates how much material and time is required to build the product. So you need to be aware of how much material is required to build the product, and if the material is very lesser, based on the thickness you can decide what is the amount of material that you require. Say for example, if there are thicker layers and the time involved for printing this particular model will be lesser compared to the time involved for this model, because it has higher resolution and it is very thin layers. During the manufacturing or printing, the layers might be not that much visible to your eyes, but the output what you get will be very great and the texture what you get will be very smooth. So here during the slicing of 3D models, you are actually giving the data or the instruction to the additive manufacturing machine, which is printing the data or printing the part whatever you require. That is why this is one of the important steps or parameters that has to be considered for additive manufacturing. Hope you have understood what is the first parameter. The second parameter is correlated with the layer height. So in the previous parameter that I discussed about the slicing of 3D models. Slicing is again depends on how you are actually slicing your 3D model. So generally the 3D models are sliced horizontally, it is horizontal layers. Now you should also be very much considerate about the height of the layer. The layer height specifies the height of each layer of the part. Okay, so why is it so much important? Because the layer, if the layer thickness or the layer height increases, it does not give you much resolution. It means that it has very low resolution. This particular part has very low resolution. You say it has thick layers, and because of the thick layers, the printing also is faster and you are not getting much details to the geometry whatever you are printing. Okay, so whereas the another example here, another model what you have has very thin layers, that means the layer height is very lesser. When you have lesser layer height, it means it gives you a very high resolution, and because of that high resolution the print involves thinner layers with a smoother surface, but it takes more time to print. Depending on how exactly you want the print to be, you can adjust the layer height, whether it has to be thicker or whether it has to be very smaller, or you can have a combination of both thicker layers and thinner layers, depending on where exactly you need the details to be very good and where the details need not be that much great. So this is why this is an important parameter that you need to consider while you are going to additive manufacturing process. The third important parameter is the shell thickness of the shell. So you understood about the slicing of 3D models, you understood about the layer height, and now coming to the model itself. So here the strength of the model has to be defined. So you need to understand what is that strength the part is getting, and that strength of the part is defined by the shell thickness. It defines the thickness of the side walls and is one of the important factors which actually defines the strength of the print. So more the number of shells, more the strength of the print is. Lesser the number of shells, less the strength of the print is. So shells are the number of layers on the outside of the print. It is the number of layers on the outside of the print. So increasing the number will create thicker walls and improve the strength of the print. You can just see here the figure depicts the number of shells. It is being increased from one shell to 30 shells. You can just see how exactly it varies, and also the thickness of the outer shell. So this is why it actually imparts strength to the print. See here the 10 shells, whatever it has sufficient thickness, and that thickness of each shell has recommendations. Here you can just see this table, the recommended minimum thickness of each shell as well as absolute minimum thickness what each shell can have, and based on different materials you have different thickness. You can just see here 1.5 thickness for PLA material, and then you have 1.5 thickness, 1.5 mm thickness for ABS, nylon 1.5. These are recommendations, but absolute thickness can be up to 0.8 or 0.6 for Vero white. Transparent material has 0.6, ABS like 0.6, rubber like is 0.8 and 2. So these are some of the material thickness recommendations that you can have, and based on that you can set the shell thickness accordingly. And if you do not want the print to be much stronger, then you can choose very less shell thickness. If you do not want much stronger, if you want stronger print, then you have to go for larger number of shells, which is actually correlated to the thickness of the shell. Okay, the fourth parameter is fill density, or you can also call it as infill. Infill or fill density, it refers to the space inside the outer shell of an object. So here in the previous slide we discussed about the thickness or the shell. So this is the shell, you can just see the shell here. So shell is present, and now you need to concentrate on the inner space whatever is present after you define the thickness of the shell, and that is where fill density comes into picture. Infill or fill density, it refers to the space inside the outer shell of an object. And suppose if an object is filled with 100% infill, that means the material is completely filled inside the shell, and that is when you call object as completely solid or stronger or heavier. You can call that as heavier. And the time and material required, if the density is more, the time required is more, and meanwhile even the material required will be more. So most of the patterns you need not have 100% density unless you require completely solid, stronger or heavier print, but you can have different structures inside the space of the shell. You can see here this is the 25% fill. This is there is a pattern which has been printed inside the shell, and it is called, or it is said to be 25% filled with the material. And moving on further, you have 50% fill, and then the last one is 75% fill. But when you take into consideration, or when you compare between all the three, the third print is stronger than the second and the first one. Okay, so the strength also increases as the density increases. There are certain patterns that you can actually use to fill the inner space inside the shell, and that is rectangular. The pattern whatever you are seeing in these models are rectangular patterns. You can also have triangular patterns as well. Then you can have patterns which is in the form of wiggle, and then you can have patterns of honeycomb shape. So these are some of the patterns which are used to fill the inner space which is present inside the shell. Once you define the thickness, you need to think about filling the inner space, and that is nothing but the fill density. Hope you have understood what exactly is fill density. Up to previous parameter, it all concentrated on the parameter of the model which is to be created. But now this is one such parameter which is concentrating on the machine side. Okay, that is nothing but the print speed. You need to have the optimum print speed so that you get a proper product or very good product with good surface finish and good quality. So print speed refers to the speed at which the deposition head travels while depositing the material. Depositing head is nothing but the nozzle, and you need to specify in what speed does the deposition head actually travel. And this print speed always depends on what is the type of the design, what is the build material, and then the process of additive manufacturing that you are using, and then the height of the layer. Layer height you have already understood, that is the thickness, the high resolution or the low resolution part, and the type of design, how exactly the design is, whether the type of design is complex or whether the type of design is very simpler, and then what type of material you are using. Even this also accounts to the different print speeds. There is a figure which is actually saying the quality versus print speed. So there is a graph which has been plotted. In x-axis you can find the printing speed, which is in mm per second, and then in y-axis you can find the quality, which is percentage. So 100% quality or 20, 30, 40% quality. Now you can just see this. This is a graph which has been plotted for 100% quality. Then you have 80, 60, 30, 15 and 10%. There are three parts which has been printed for different printing speeds. The first one is printed at 10 to 15 mm per second as the printing speed. The second one is printed at 60 mm per second, and the last one is printed at 120 mm per second. So here, as the printing speed increases, this is the increase in printing speed. When you increase the printing speed, even the quality also decreases. So here you can see the quality is very poor, and in this particular model you have average quality that you have got. But if you have to get a very good product, then you have to choose the printing speed somewhere lesser, and that is when you actually get the good surface finish. For this model, if you want to get this type of surface finish, then your printing speed should be somewhere in between 10 to 15 mm per second. So from this you can actually understand, lesser the printing speed, more good is the quality of the product. So when you are giving more details, or when you want the product to be very good, very fine, very good surface finish, then always choose lesser printing speed. If you do not want, or if you are not bothering about the quality, then you can slightly increase the printing speed, say up to 50, 60 mm per second, and then get the product wherein you can just use it as a prototype to understand how exactly the product looks. So there the quality have to be compromised. If you do not want to compromise on the quality, just start with the lesser printing speed. That is one of the important parameter. Yes, the next parameter that is very much important is supports. So supports are the structures that hold the 3D objects that don't have enough base material to hold while printing. When the materials, or when the part whatever you are printing do not have enough base material to hold its branches or hold its other parts, then you need to have the supports. Supports ensures that material is deposited at intended height and the expected output geometry is achieved. So here you can just see three figures. The first one here do not have the support. When you do not have support, and the second image tells about the part which has been printed using the support as well as the raft, and then the third one, it says after the supports are removed, this is what the output is. So now you can just see this. I'll just zoom. So here what you can see is, when you have not used this, in the first image you can just see the tail has been broken. So here the breakage of tail during the printing happens because of no support given, and also the quality of the product which has been got without the support is very poor compared to the quality of the product what has been got with the help of the raft and the support. Say for example, your head has to be printed, the head of the part here, if it has to be printed, can you just see the support given here? This is the support, this is nothing but the support given to that, so that the head is printed at the intended height and you get the expected geometry. Okay, even here there is supports which is nothing but it is actually supporting the body of the animal here, and then support for supporting the tail of the animal. So whenever you have overhanging structures, there you need to have the supports, you need to give the support so that it will actually be printed at an intended height and you get a expected output geometry. That is why supports are also very much important. You need to define it before starting the printing. If you do not define it before starting the printing process, then your output will not be as expected. The seventh parameter what is important in additive manufacturing is platform adhesion. So you need to build the part on a particular platform, and that is why platform adhesion is very much important. You need to adhere your print onto the platform. You cannot just choose any platform on which you can print the material or print the part. So here there are two such platform adhesion. One is raft and the other one is brims. And what is raft? You need to understand what is raft and what is brims. A raft is a horizontal lattice work of the filament that is located underneath the part. Say this is the part what you are actually printing, and you need to have a proper raft for that or a platform for that on which you build the part. It's nothing but like a cup and saucer where you keep the cup on your saucer. So it is nothing but it exactly holds the part in a proper way, and also once you finish building the part you can remove it very easily from the platform. So that is what it means. So one such platform adhesion is nothing but the raft. It is a horizontal lattice work of filament that is located underneath the part. The part will be printed on top of this raft instead of directly on the build platform. So instead of you building on the platform directly, you need to have such platform adhesions so that you can remove the part very easily after it is being printed. Say for example, you do not define a platform adhesion and you start printing on the build platform itself. At that time, if there are any chances of the material getting stuck to the build platform, then the removal of build will be very much difficult. So in order to avoid that, you can have the raft which is made up of same material as you are printing. Before starting of the printing, this raft will be printed and then on that the printing starts. So that is why the platform adhesion is very much important. And then brims. Brims are just lines around the bottom of the object which keep the corners of the model down without their leaving marks. So here you can just see. So when you compare raft and brim, brim is much more thinner than the raft. So brim, it exactly gives you just the lines around the corners of your part so that your part can be printed on that and then finally take out and remove it very easily. So that is why this platform adhesion is very much important. If you do not have a platform adhesion, then removal of the part becomes very much difficult. The final parameter what you need to understand is initial layer thickness. So we have seen enough parameters, and this initial layer thickness, it refers to the thickness of the first layer on the print bed. So after slicing, what you do, you transfer the model to the machine and then you set all the parameters, and while giving the first layer thickness, you need to give the larger thickness, because sturdier base, if you require a sturdier base, then initial layer should be made thicker. So if the layer thickness, say for example, is 1.5 or 2 mm, then the initial layer, if you print 5 mm, then the 3 mm will go for the support or the base, so that you get a proper print. To obtain good adhesion to the bed, the lines of the first layer need as much surface contact with the bed as they can get. So you need to always give initial layer more thickness than what the layer thickness you have defined. That is what this means. So these are certain parameters what has to be considered during the additive manufacturing process. So now after you have understood different stages and as well as different parameters that is necessary for additive manufacturing, we'll see what are the advantages, disadvantages and certain applications of additive manufacturing in the coming slides. So advantages, disadvantages of the additive manufacturing process. There are so many advantages and disadvantages. I have just picked a few of it and then I am explaining it to you. One of the important advantage of additive manufacturing process is that it is easy to fabricate complex shapes. When you consider the conventional manufacturing method, the complex shapes, if it has to be manufactured, it takes lot of time and lot of process planning is required. But in 3D printing, you can actually fabricate the complex shapes very easily, and you have reduced lead times. The total time involved from customer order to delivery will be drastically reduced if you consider additive manufacturing process. Then less production labor, material waste and energy consumption. So you need not have much labor in your factory, and the material waste will also be lesser. Whatever the material is used from the machine is directly you are directly getting it as the output. So the material wastage is very much minimum. You can also say it has little or no wastage at all. So the material which is getting wasted will be very lesser. And then production is possible without costly and time consuming tooling. So it is very much true that if at all you want to produce complex shapes, then you require in conventional machines, I am talking about conventional machines, if you want to produce complex shapes, then you require the tooling which is to be very higher, and also you require some specific tools for that. But here in additive manufacturing, that is not the case. You need not have time consuming tooling. Disadvantages, yes, the build rates are very much slow. And then the surface finish and dimensional accuracy of the additive manufacturing process is very much low. And the other main disadvantage is that only one part at a time is produced. It is a discontinuous process. You cannot have mass production here. You need to first print one part and then part by part you need to print. And then the component size is very much limited. It all depends on the build platform size in x-axis, y-axis, how much the machine, whatever the machine has been designed to, only that much size you can print, not beyond that. The mechanical properties is also very much poor, and if at all you have to use additive manufacturing, then you require extensive knowledge of material, design and machine is also required. You need to have extensive knowledge of material as well as the machine. If you do not have this knowledge, then the usage that you do with additive manufacturing is very much limited. So finally, the applications of additive manufacturing. Additive manufacturing has lot of applications. Out of that, some important applications of additive manufacturing is to produce prototypes during a product development phase. You are developing an indigenous product and you have designed it in a particular manner. You need to look at how exactly the product is when it comes out as the final product. At that time, you go for additive manufacturing. And then parts for pilot series production in medical, automotive and aerospace industries. Pilot series production is nothing but the initial series of production. So during that initial series of production, then you go for additive manufacturing. Then short series production, where tooling costs for casting or injection molding would be too high. When you have this situation arising, then you can easily shift over to additive manufacturing than using the conventional methods. Then the next application is that parts of high complexity which cannot be produced by means of conventional manufacturing, you can use additive manufacturing as well. Additive manufacturing has been used by so many domains of manufacturing sectors now. Automotive industry, there is lot of application. Health industry is actually using additive manufacturing a lot. And then you have defense applications, military application, and then jewelry industries are also using additive manufacturing because they have the material which can be printed very easily, and then the design what they can obtain is also very much complex design. You can just see the images here. This is healthcare industry for transplanting the leg. and here you can just see one of the part is replaced by additive manufactured product in the automotive industry. Then you have turbine blades, then you have jewelry industry here, then you have turbine blades again here. There is so much of application for additive manufacturing, so it is one of the current technology what is being used in mechanical engineering. So if you learn about this more, then you will be benefited and then you can make a career out of it. So thanks for watching this lecture. In my next lecture, I will be explaining more about additive manufacturing. Please share the YouTube channel with your friends, like it and then subscribe it. Thank you. Thanks for listening.